Hello everyone, I am going to explain about the optical activities of biopolymers. For polymers, it will be reasonable to express optical rotation and CD in terms of quantities referred to one monomers. M dash is equals to M naught by 100 theta sp, where M naught is equals to average weight of the molecular. We can be solvent taken into account by a Lorentz corrections instead of M means rotations of monomers. So we get this equations where N is refractive index 3 into n square plus 2 is equals to 0.795 at 600 nanometer and 0.7306 at 185 nanometer. In some cases, biopolymers exhibit dual chirality. The chirality of monomeric unit and then alpha helix of proteins and polypeptide. But on denaturation, that is on helix coil transition, only chirality of monomeric is retained. This transition are done by sharp changes in rotation and CD. This very sensitive to change conformation in this application of AORT and CD have valuable information of biopolymers and changes. Far away from regions of absorption, the reduced rotation is done by Direct formula, that is M naught is equal to summation of AJ lambda j to the power square by lambda square minus lambda naught square. Lambda is equals to wavelength of incidence. Lambda dash and AJ are constant. When we combine with the equation 1, we get M dash is equals to A naught lambda naught square by lambda square minus lambda naught square. This explains the optical rotation of polyammonia acid in a colloid state. So we get this equation where A naught alpha and B naught alpha are constant. Alpha helix is obtained at lambda naught is equals to 212 nanometer. B naught alpha is equals to minus 630 nanometer. When we separate this, we'll get alpha naught is equals to this much, and then A naught is equals to A naught A to the power of A plus X to the power of alpha, where A naught is rotation due to the amino acid, where this is the fractions of the helical. So we get this equation where B naught A is small and lie within plus or minus 50, and A naught A is obtained from rotatory dispersion. To find X alpha, we find lambda square into lambda naught square minus 1 against lambda square into lambda naught square minus 1 to the power of minus 1. This gives straight line with slope of lambda naught B naught to the power of alpha. Intercept is equals to A naught A to the power of A plus X alpha A naught A to the power of A. The degree of the value are constant in Moffitt equation. X alpha is determined in value of number of proteins. This agreement is obtained by X-ray structure analysis. The quantum mechanical theory of optical activity for hemopolymers. So the calculation of rotationary strength depends on 0 minus J. When it is stronger, larger POJ. When it's smaller, MJO. In weak, it is vice versa. The sum of the extents of rotationary strength over all polymers is equals to 0. AORT and CD curves of rotation existence and the non-existability for conservative and the non-conservative. The theoretical CD curve for an alpha X with 20 turns, where pi is equals to pi naught R into 10 to the power of minus 40, where we get minus 2 to 1 and 321 and minus 100. For non-existability, we get 3.8 minus 8.6 and minus 17.7. By Moffat formula, the value b0 we get minus 30. So this is the figure of this is for non-existential, and this one is a existence. Another regular form of the polypeptide chain B0 form is by the Moffat formula. AORT and CD curve for L polypeptide. We have to use induced optical activity polymers of dye. This effect is accounted for denaturation. So the same behavior is shown by 10A for prosthetic group and prom enzymes. AORT and CD in the absorption gives the pyroxyl phosphate. The coenzymes of as separated aminotransversa have a furnished information structure of activity of an enzyme. So this is the graph or figure of this AORT and the diagram for L polypeptide, and this is for the hemoglobin and deoxyhemoglobin and oxyhemoglobin and carboxyhemoglobin. So we'll get this graph. Hemo group itself is symmetric. This is to have solutions of electronic vibration problem. The optical activity of nucleotide, DNA and RNA is by RAOT and CD in 260 nanometer by nitrogenous band. This is replaced by beta rhizobes or rhizobes by alpha compound, where delta E is equals to 1 by 3 delta E naught plus 2 delta E with orientation of DNA molecules. Delta E naught is equals to 1 minus Q delta E plus Q delta E. So we get this graph by delta E is equals to 1 minus Q delta E. So here delta E and delta E naught are measured amplitude of CD. Delta E naught and delta T are value of CD along alpha X. This optical is named as hidden. Optical activities by studying DNA and RNA by Makar and Pollet. It has been established that di molecule in complex are perpendicular to alpha X of nucleic acid. So this is all about the optical activity of the biopolymers. Now this is all about the activity of the biopolymers. Now I am going to explain about the magnetic optical activities. So in magnetic optical activity, this was found by the Faraday. He wrote in a diary so that it was discovered the magnetic rotations of a plane of polarization of light, propagation along along direction of magnetic field. This phenomena is called Faraday effect. In his diary, the meaning is the magnetic field act not on light but on substance that exhibit circular bifragments in field. It has two types. First one is a magnetic optical effect and next one is a magnetic circular effect. So this is the formula. Alpha is equals to pi by lambda and L minus Nd into L is equals to the constant L H, where this is a constant of the magnetic rotation. This is also called as Vertet constant. The Faraday effect reduces the Siemens effect. In the absence of magnetic field with circular frequency, where angular frequency naught is equals to we get angular frequency H is equals to minus E H by 2 m is C, where E and me are electronic charge and mass. C is a light velocity. So we get these equations, and then where lambda is a light wavelength. So we get this equation by that. So next, this is called as a Becquerel's formula. The ground energy level of the electronic system is split. That is, instead of angular frequency naught, we have the W L is equals to W naught minus lambda H. So in this is for the first level, and the second level EL is equals to E 1 plus HB, and ED is equals to E 1 minus HB in the second level. In the third level we get L is equals to W naught constant E H, and then we find this equation, and then by expanding delta E we'll get this A naught plus AE plus B plus C by KT. There are two electronic degraded existed level. E has a result of MOR, that is magnetic optical effect, and asymmetrical curve of delta E, vice versa. In W we get a magnetic circular effect. Finally, type C arises as a result of a degradation of E naught. In accordance with the Boltzmann's law, the C type effects are asymmetric in MCD and asymmetric in MOR. So we get this graph. We can see the graph or the figure. So from this figure we'll get this equations, this equation, and this is for asymmetric OR, and this, and we get these equations by that graph. The Faraday effect is no way connected with the natural optical activity of chiral and the achiral molecules. Optically active substance is constant for and disappear while Faraday double. Experimental absorption of anomalous and magnetic rotations and circular dichroism successfully. Strong magnetic at relatively weak absorption, for example profiles compounds, hema contained protein, chlorophyll, etc. The relative value of MCD for various organic compound: 100 for polypropylenes, 3 for alurins, annuals, about 0.2 for purines, and 0.002 for cyclohexanes. These effects depend on electronic states of hema and conformations of proteins. The fine structure is present in absorption of spectrums. The high sensitivity of AMRT and MCD makes it possible to study the various cytochromes in suspension of submitochondrial particles. So this is a graph for this explanation. So I am going to end up here. Thank you so much.